Okay, in this class, we are going to be looking at how we are going to generate an expression for linear expansivity, or what we call coefficient of linear expansion. So, and then after we are done with that, we will still look at how we can um, get an expression for the final length of the material when it must have expanded. So that is the equation we are going to look at briefly so we can generate that. So looking at this diagram, we can see that this is the length of a rod. So already the experiment, we have done that in the class. So what we are saying is that assuming that this is the original length of the rod, so and it is labeled L1, and then I have when the rod must have been heated and then it increases in length, so that it expanded. So it expanded from here now to change in length. So this little dotted line here is the increase in length. So that means that the change in length is equal to L1, L2 minus L1 because it increases from L1 to L2. So this is the change in length, which is L2 minus L1. And then what is the linear expansivity? So from our understanding of linear expansivity, we know that linear expansivity is the increase in length per unit length per degree rise in temperature. So doing that mathematically, so we have that linear expansivity is increase in length over original length multiplied by the change in temperature, so which is theta 2 minus theta 1. So this is our expression, our expression for linear expansivity. So if linear expansivity is actually change in length over original length multiplied by the change in temperature, so we are now going to look at how we can now find the final length reached, maybe after the rod must have been expanded. So that is what we are going to look at. So in that case, we are going to cross multiply. So we are going to cross multiply this. So when we cross multiply that, we have L2 minus L1 is equal to theta multiplied by this. Alpha multiplied by this, we'll have alpha L1, then bracket theta 2 minus theta 1. So this is it. Okay, now what do we do next? So we now try to make L2 the subject. So we're trying to make L2 the subject. So doing that, we now have L2 is equal to, so we are taking L1 to the right hand side, and then it becomes L1 plus, it is changing from minus to plus now, alpha L1, then theta 2 minus theta 1. So this is it. Now, when we look at the expressions here, we can see that L1 is here and L1 is here. So what we do is that we try to factorize it. So factorizing, we have L2 is equal to L1 plus alpha L1 change in theta or change in temperature. Okay. Now, factorizing this, so we have L2 is equal to, so we take the common one, which is L1 in bracket. So we are left with 1 here plus, then here we are now left with alpha change in theta. So we have alpha bracket theta 2 minus theta 1. Okay, so that's it. So let us take change in theta to be delta theta. So what I mean is that we are going to take theta 2 minus theta 1 to now be delta theta, which is change in theta. So putting the expression back here, we have L2 is equal to L1 open bracket 1 plus alpha, then change in theta. So, and this is our expression for the final length of the rod when it is heated from L1 to L2. So that is what we are actually trying to derive. So that's it.